So now let's just have a look at this example. So now in this example we are given two sets. Set A, which has these elements, and then set B. Now our relation is defined from set A to set B, where x or y. X or y means element x is connected to element y, where element x, the first element, belongs to the first set A and the second element belongs to the second set B, where x or y means y is equal to 2x, means these two, the elements of these two sets are connected when the element of the second set is double of the element of this first set. This is the logic. So if I just draw this, so we can see that the elements in this set were 1, 2, 3, 4, 5, and elements in this set are 8 and 9. Now we are told that these elements are connected when y, which belongs to this set, is double of the element of this set. So can we see that in this case, this 1 is connected to 2, double of 1. And in this example, we can see that this 1 is not connected to any other element, because y should be equal to, so 1 at least. 1 is only connected to 2. Now again, with the same logic, we can see that this 2 is connected to 4 is double of 2. And according to this logic, these two are connected. So this connection is actually the relation. Is the relation. Six. And this 5 is not connected with this 9. So I've just taken this example so that we actually are left with some elements in this set and some elements in this set which are not connected to each other. So it is a possibility. It is not necessary that every element should be having a connection. It is not necessary. So in this case, we can see that if I have to write down this relation, nobody is going to ask us as such. But in this case, the pairs which would come would be 1, 2, 2, 4, 3, 6, and 4, 8. This would be the set of pairs which would be there for this relation. These are the relations which are existing in this example. Now comes some new terms. So these new terms are going to actually last for very long actually, and we are going to use them for so many times. So just understand these new terms. So the first new term is actually domain. Domain of our relation. Domain of our relation. So domain of our relation actually starts those elements in the set A. Those elements in the set A, which is the first set, which have a connection with elements of set B. So what does a domain means? Those elements of set A which have a connection with elements of set B. So in this case, we can see that though the set A was having 5 elements, but only 4 of them are connected with elements of set B. So if this the domain of this relation R, we can see that it would be only 1, 2, 3, 4. Beside this number 5. Why? Because it is not connected. So domain is those elements of set A which have a connection with elements of set B. So another mathematical word which we use to actually represent this connection is actually reflection. And it matters much whether you use this word or not. The specific term is reflection. So if elements of set A, those elements of set A which have a reflection elements of set B, the domain. So in this case, the domain would be the first name, and you are hearing it for the first time. So just try to just grab this word for the first time itself, but otherwise it's okay because we are going to use it for so many times in the coming examples as well. So this is the name, domain of a relation. Now comes the next name, which is codomain. Codomain is nothing. Codomain is simply set B. codomain is simply set B. So we don't need to worry about this name much. So codomain is what? The complete set B. Nothing special. It's just another name of the other set B. But the interesting name which comes is actually range of this relation. And these two names are actually interesting because they would just come in so many questions, ultimately in functions, and we are going to use these two names many times. So domain is what? Those elements. And similarly, range of a relation means those elements of set B. Those elements of set B now which have a connection with elements of set A, which are connected to elements of set A. In a way, it's the same sense which we have heard over here. So in this example, the range would be, we can see that 2, 4, 6, 8 are connected with elements of set A. So those elements in codomain connected with elements in the set A are actually part of the range of that function, of that relation right now. So in this case, the range of this relation would be only these 4 elements, 2, 4, 6 and 8. 9 wouldn't be there. Range is what? Just make yourself actually speak this line, that range of a relation is those elements in the codomain which have a connection with the set A. So exactly this is the definition. So we can see that in this case the range of this relation is these 4 numbers 2, 4, 6, 8, and this is the domain. And we are going to look at this example for so many times, and we are going to use it for so many times that ultimately just seep into your mind. So now let's do one more example and try to actually answer it by yourself while listening to me, so that you are now well versed, you know the name, and after just understanding this name, any kind of question which comes in front of you, you would be able to solve. So this is the understanding.